So you take a database and then you take a particular table. In this case, it considers a user table. User table itself can be very big and depending upon some customers' information. So what you want to do is you take the user table and you want to find a logic on the key where you can distribute that data across many databases. Let's take an example. Here in the user table, you have users starting from A through D, A through E, because the alphabets. So what you want to do is you want to take this data set and then you want to find a way to distribute the data set across multiple shards. Let's stand up a couple of examples. So you have another database. In this database, what you want to do is take this particular data set and anything with A through D, you want to distribute into this new shard. And then you stand up another shard and then you distribute users starting from E through G. Like this, you can go and distribute the data up to Z. Once you distribute the data, you want to know how the data, when you want to retrieve the data, you have to know which shard to go to pull the data back. So for that, you want to stand up a mapping table, so where you say users from A through D are in shard 1. And then user E through G in shard 2. So by having this mapping, when the front end or middleware want to retrieve the data, as an example, user Alex comes in. So you want to know the information about the user Alex. What you want to do is you want to hit this table first. Okay, this user A can be found in shard 1. Then you want to go to the shard 1 and retrieve the data for that Alex user, and then you want to present it back. So this is for the range-based sharding. Advantage of range-based sharding is amount of business logic you want to keep that is very simple. You can keep it in the memory, because if you're going with alphabet, you're going to have only so many rules that you can keep everything in the memory, and then every time an application logic needs to validate the data, they can hit that particular table or in-memory file. They can say if the user Alex come in, they want to know where the user the Alex is located in which shard. They can just hit that particular in-memory table or file. In this case, A is located in shard 1. It can go to shard 1 and retrieve the data and present it back. So this is one thing we want to watch out in this particular implementation is if we are going with alphabet-based sharding, there are some usernames like starting with S or T. That particular shard can get a lot of data. That particular shard also can be bloated, where you will have a lot of hotspot in this particular implementation. So you want to find out what is the right way to do the distribution. So you want to say maybe the S and T could be a database shard instance by itself, where you go to the Y and Z and W, Y and Z. Those can be in one shard, but S by itself could be a one shard, or T by itself could be one shard. So that's one thing you need to watch out in the range sharding. But the implementation is in the range sharding, we know there's a chance for a particular shard to get hot or bloated. So how do we implement? How do we achieve a equal distribution or even distribution? So let's take an example. ASCII based sharding. So the same example, you take a user table in the database. So this is a user table. You want to take a user ID, username in this case. If you want to do a key based sharding, you take the username and then you apply MD5 of username, and then you can also and make it as a readable, which is a base 64, and then convert that into a number value. So when you do this one, then you'll get a number. Then you basically take the number and say anything number 000 through 1000 go into this sharding. So it's in this case 000 to 1000, this sharding, shard 1, and then 1001 through 5000 goes to shard 2. Then you create a mapping table 0, 0, 0, 0 through 1000 shard 1, 1001 through 5000 shard 2. So what's the advantage of doing this way? Advantage is when you take a username and you apply a modify and then you do a base 64, then the data is very evenly distributed. Alex, and then you have Alicia, and then you have Aloysius. When you have different names with the same starting with A, but the MD5 value, it's going to be very different. And then when you calculate the numeric, take the first or one of the 4 digit of the numeric value, then there's a good chance that Alex will go here, and then Alicia will go here, and Aloysius may go to another sharding itself. So in this way, your distribution will be even, and then you can also make sure not one of the particular shard is not overloaded or hot, so that you can have a even distribution based on the hash key. So this implementation is a little bit I would say complex, because every time when you want to retrieve the data, you have to apply the same mathematical the equation, where you need to identify and then go against this particular table to understand where the data is in the shard. And also, whenever you load the data, and you have to do the similar thing, you want to apply the same logic, and then you want to make sure you are either inserting the data or updating the data into the right particular sharding. So the complexity level compared to the vertical and range based, here you need to make sure there's some logic goes into that, both for the data loading as well as the data retrieval. The advantage of doing this key based sharding is your data is distributed evenly, so that you won't have a lot of hotspot in the shards, and then you can also manage and measure the growth for the particular shard. All right, so now let's talk about the next